This case study is about cetaceans and the adaptations necessary for moving around in the water. Usually I start this lecture out with a think, pair, share exercise. How do you turn a cow, an artiodactyl, which is the sister taxa to cetaceans, how do you turn a cow into a whale? So the kinds of things that tend to bubble up in those kinds of brainstorming sessions are you have to change locomotion because you're moving from a terrestrial environment to an aquatic environment. You need to change feeding adaptations because you're not in an environment with lots of vegetation anymore. You have to make use of other food sources. You have to change your sensory systems because vision doesn't work quite so well. Hearing works a lot differently. And you also need to change temperature regulation because the water causes animals to lose heat very quickly due to convection. So we're mostly going to be focusing on locomotion, but some of the adaptations for locomotion also have impacts on the other kinds of things that need to change for living in an aquatic environment. So first, let's look at some of the morphological characteristics that are associated with being fully aquatic. Just going to blow this up just a little bit. So the first thing is that cetaceans have what we call a fusiform shaped body. It's sort of cigar shaped. It's kind of rounded at the end and then tapered to be a little bit more slender towards the tail. They also tend to have a very large body size compared to terrestrial animals. They're virtually hairless, so they tend to have a few vibrissae around their facial region, but for the most part, their body is not furred. Instead, to insulate them against heat loss to the water, they have a very thick layer of subcutaneous fat or blubber, and that gives them this fusiform shape. It makes them buoyant in the water so that they float pretty much on one level without sinking or rising. And it also insulates against heat loss. Because they have no hair on their bodies, they don't have sebaceous glands. Remember, those are the skin glands that are associated with hair in mammalian species that have body hair. They don't have the hair, they don't need the glands. Their tails are flattened to serve as flukes for propulsion. So by going up and down, the tail propels the animal through the water. So we say that this is dorsoventrally flattened, flattened from top to bottom. The front limbs are modified into flippers, and these don't propel the animal through the water. They just serve to stabilize the animal as it's moving through the water column. So it just makes its path a little bit more steady. They still have the bone structures that most mammals have within their hands, so the carpal bones and the metacarpal bones that make up the digits, but they're all just enclosed inside this webbing to make them into a flipper. The hind limbs are vestigial. That means that you can find little remnant bones of the pelvis and the hind limbs in some species, but there's nothing really that shows up outside of the animal's body. Most species also have a dorsal fin. It sticks up on the top of their bodies like this, and much like the front flippers, it serves to stabilize the animal as it's moving through the water. So it's like a rudder on a boat. So in our lecture outline, most of these links just take you to other examples, pictures that show you the characteristics. And I'm going to leave it to you to check out those links, except for this one about vestigial hind limbs. So most cetaceans don't have any externally visible hind limbs, but every once in a while there's a developmental error that causes some to be born with little nubby hind limbs. And so this article talks about how that happens and shows embryologically how the hind limbs start to develop as buds. Here's the front limbs, and you can see their finger structure. And the hind limbs are starting to develop right here. and then over time they disappear. And most whales and dolphins don't have any observable hind limbs, except for if you take an X-ray and see some of the vestigial bones of the pelvis. But every once in a while, they are born with little nubs of hind limb flippers. And it's just sort of an error of development, but it does show you that the genetic program for the hind limbs is still there. It's just had a mutation that's changed how that plays out during development. There are a few other characteristics that are associated with living life in the water. If we look at the skull, the rostrum, the nose part, is especially long in cetaceans. And this is associated with the nares, or the nostrils, moving farther back on the cranium. So this picture that I'm going to blow up here, whoops, went a little too far, shows a fossil of an early cetacean, and at the end of its elongated rostrum you still see the nares opening here in the place where you would expect them to be if it was a terrestrial animal. But by 25 million years ago, the fossils are showing the nares opening way farther back on the rostrum, kind of at the base of the rostrum. And if you look at modern whales, the nostrils open up at the top of the cranium. And this makes it a lot easier for them to inhale and exhale quickly as they surface to get water. It also enables the oral cavity and the nasal cavities to be completely separated. So in terrestrial mammals, you have that crossing over that occurs in the back of the throat that enables sometimes liquid to go down the wrong way into the lungs. And that would be a huge problem for an aquatic species. So they've evolved a separation of those two passageways. And part of the thing that's enabled that is this movement of the nostrils farther back along the skull. Another thing that we see is that the bones of the skull are telescoped. That means that they extend farther forward and farther backward than in terrestrial species. So here's a baleen whale, and in this case we're looking at these cranial bones, especially the maxillary bone here, that extends far out to increase the length of the rostrum, but it also extends underneath the orbit, so it's extending farther in both directions, and it serves as an attachment site for baleen, which enable the whale to strain the food items from the water. Another specialization is the blowhole. So since the nares have migrated far back, they have an opening in the top of their skull now that's called a blowhole. And the blowhole is closed when the animal is underwater and only opens very briefly when the animal has to take a breath, either exhaling or inhaling. So that prevents water from going down into the respiratory passageways. Finally, their necks are really short, and that's often accomplished by fusion of the cervical vertebrae. So that makes the morphology a lot more rigid, gives it this fusiform shape instead of having a floppy neck or a skinny neck that allows the head to flop around. It's all tied together into kind of a compact package that moves very, very efficiently through the water.